Okay, so we're going to talk about properties of atoms and elements. So I thought this meme was kind of funny. Don't trust atoms, they make up everything. So atoms are something that make up everything that has matter. So it's in our atoms are a part of our cells, they're a part of the table that's in front of you, the animals that are in your lives, the grass, the trees, the sweeper in your house, the plates that you eat off of. It is the smallest basic unit, and it makes up everything. So if we look here at the structure of an atom, this is kind of a picture that you will see a lot of times when they talk about an atom. So you see that there are these swirly lines here on the outside, and then there are these tiny little dots here, and then there are these balls here that are in the center. And every atom has that basic structure. Now, there are different components to an atom. On the outside is the electron cloud. That's what these lines out here are representing. That's just a region outside of the nucleus of the atom where these electrons are contained. And so they call it a cloud because it's not a specifically defined region, it's just that area around the nucleus. Now, the electrons are on the outside here as well, and every atom or element has a specific number of electrons. Now, the further that the electrons go away from the nucleus, the more unstable they are and the more they are able to participate in chemical reactions. So the electrons that are on the furthest point out are called the valence or valence electrons, and those are the ones that typically do participate in different chemical reactions. Electrons have a negative charge, and they typically contribute a lot to the weight of an atom or the mass. Here in the center, these red and blue regions here, those are the protons and the neutrons. So the protons are going to have a positive charge, and like I said, they're located in the nucleus, and they're what defines the element. So on the periodic table, you will see that all of the elements are numbered, and that is what that number indicates, is the number of protons there are in the nucleus, which we'll look at in the next slide. And then finally, there are also neutrons that are in the nucleus, and they are something that has a neutral charge. And so you have those protons and neutrons in the nucleus and the electrons in the outer electron cloud. And all those things put together make up an atom. So atoms have to be able to interact with one another. And so if you think about all the different compounds that we have, think about water, carbon dioxide, nitrogen gas, even think about more complex things like sugar or oil or even coffee and all the different medications that we have. All of those are compounds. And there's also something called a molecule. So these are very closely related, but they're not exactly the same. So here in yellow, you can see that I've said all compounds are molecules, but not all molecules are compounds. So what I mean by that is that compounds are when two or more elements or atoms are brought together by a specific type of bond. And we're going to talk about bonds later. So it just has to be two or more different types. But a molecule is when you have when you create something by using a bond. So the difference being that a compound, like on the left, you have two different types of atoms. So this is a molecule of carbon dioxide. So the red are the oxygen and the black is the carbon. And that's two different elements. So that is a compound. And it's also a molecule because you're using bonds to bring two different atoms or elements together. Now on the right, you have oxygen, which oxygen that we breathe in is something that it's not just O, it has to be O2. Anytime you see oxygen, you always see O2 because when you get to chemistry, you'll learn that it's a type of um, element that has to be paired with something else to be able to be functioning. So that is considered a molecule because there's a bond between those two oxygen molecules, but it's not a compound because there's only one element present. So to take away from this, compounds have to have two or more elements, and molecules, you are just using a bond to bring two atoms together. Okay? And I think, so let's go back here and look at what elements specifically are. So elements are like the pure form of a substance. So if you look at the periodic table, all of those are elements. And things like gold, tin, helium, hydrogen, nitrogen, fluorine, tungsten, silver, all of those things that I know most of you have heard of. And so, like I said, each element has some defining characteristics. So on the periodic table, you will see that it has the symbol name for each element. This is carbon, for instance. It's going to have an atomic number at the top. That is going to equal the number of electrons and the number of protons. So most elements in their natural state are going to be what we say is neutral, meaning it does not have a charge. And so the number of electrons and the number of protons must be equal. So think about that. Think about that in terms of math. If you have a positive 6 and a negative 6, that's going to equal 0. And that's neutral in the case of chemistry. So elements in their natural state are neutral because that's when they're most stable. And so that they want to always get to that most stable state. And there is also something called the atomic mass, which is at the bottom here. And that is the average mass of all the isotopes. So isotopes are basically just different forms of an element that have different numbers of neutrons. And so they average all of those to get an average mass. So remember, mass and weight are different things. So you have to take into account gravity when you think about the difference between mass and weight. And so in this case, the atomic mass for carbon, 12.01, is the average of all of the different types of carbon. So there's carbon 12, carbon 13, carbon 14. So carbon 12 is the most common kind of carbon that we have in all organic compounds like us and dirt and trees and things that are living are called organic. And these other types of carbon, they use in carbon dating for fossils and things like that. So now that we kind of know what elements are and what compounds are, we have to learn how compounds are formed. So there are kind of 4 main types of bonds that I would like you to be able to understand. So the first being a covalent bond. So a covalent bond is when 2 atoms share a pair of electrons. So we're going to flip back and forth between slides here so you can see a picture. So that would be this first one here in the upper left. So once again, I'm going to use the example of carbon dioxide. So carbon dioxide, you should all know, is something that's what we breathe out, what plants use to create oxygen in photosynthesis. It's what we talked about that's emitted sometimes by factories, things like that, is what's called a greenhouse gas. So carbon dioxide is a perfect example of a compound that uses a covalent bond. So that means that they're sharing electrons. So I talked about how they share their valence electrons. So that's what's happening here. They're sharing electrons. The next type is ionic. So this is where ions are created. And ions are simply atoms that have a charge. So that could be positive or negative. So if